Tere hommikust! Tervitan teid kõiki Tallinna Tehnikaülikooli siin 6. korpuse suure amfiteatri seinte vahel ja peab tunnistama, et tavahommikul see auditoorium küll kunagi nii täis ei ole ja ma saan aru, et registreerimise laua taga on veel väike järjekord, nii et võib-olla lähevad müüki ka seisukohad. Igal juhul juba vähemalt 5 aastat oleme korraldanud sellist üritust nagu projektijuhi päev ja varasema traditsiooni järgi oleme korraldanud seda üritust Tallinna Tehnikakõrgkooli seinte vahel Tõnismäel ning sel aastal, seega 6. korral, otsustasime natukene vaheldust teha ja seega siis Mustamäe mändide all. Tänase ürituse peateemaks, nagu te ekraani pealt näete, see on siis ehitusjuhtimise kaasaegsed meetodid. Ühest küljest jõle hea meel, et selline pealkiri on kokku kutsunud sellise rahvamassi. Selleks, et te kõik, kes te päev otsa siin teineteise ja üksteise kõrval istute, saaks aru, kes teie auditooriumi kaaslased on, siis kõigepealt siin auditooriumis on neid, kes tänaseks päevaks on jätnud maha oma käitisepingid ja tootmistsehhid ja seega projekteerija lauad ja projektijuhi ametid. Seega olete tulnud ärivaldkonnast ja kuulate, mis juttu siin räägitakse. Siis eriline rõõm on tervitada neid tudengeid, kes rotsides tänast külma ilma ilmselt poole öö ajal hakkasid meie lõunaosa riigist Tartust Tallinna poole liikuma, seega siin on grupp Maaülikooli tudengeid. Vähemalt tean, kunagi 100 aastat tagasi Tartust Tallinnasse tee võttis aega 2,5 päeva, nii et loodetavasti täna nad said ikka tõesti 2,5 tunniga hakkama. Siis on Tallinna Tehnikakõrgkooli tudengid siin ja siin on ka loomulikult meie Tehnikaülikooli tudengid. Nii et auditooriumis saavad kokku siis reaalne igapäevane praktika ja need, kes teile hakkavad kuklasse hingama, tudengid, kes lähiaastatel lõpetavad. Natuke mõtisklust antud teema osas. Seega kaasaegsed meetodid ehituse juhtimises. Kui siin auditooriumis on natuke vanema põlve inimesi, siis mäletate, kunagi oli Eesti Televisioonis üks telesaade, mis kandis nimetust Täna 25 aastat tagasi. Jah, Valdo Pant seda juhtis ja need, kes seda saadet teavad, mäletavad, millistest teemadest siis juttu oli. Aga ma võiksin ka praegu öelda täna 25 aastat tagasi. See oli siis 80. aastate lõpp, 90. napikas algus. Mäletatavasti siis, meil Eestimaal olid teised ajad veidi, aga Euroopas oli tol hetkel ehitus- ja kinnisvaraturu sõjajärgse perioodi võib-olla üks raskemaid kriise. Sel hetkel ehitajad rabelesid hingehinna eest, selleks, et ellu jääda ja turul toimetada ja ega meelakkumine ei olnud ka tellijatele. Ning sellistel rasketel kriisiaegadel on toimunud kõige rohkem revolutsioonilisi ja evolutsioonilisi muudatusi just nimelt ehituse juhtimises. Sest mõtleme kõige lihtsamas mõttes ehituse tehnoloogia peale. Ehituse tehnoloogia on täiesti võrreldav maailma kõige vanemate elukutsetega ja ehitustehnoloogias klassika, nii nagu me müüri laome, nii me oleme ladunud seda tuhandeid aastaid. Enam-vähem betooni ja naela lööme ka seina sisse samamoodi nagu seda on aastasadu tehtud. Kuid kui rääkida kaasaegses mõistes innovatsioon, siis innovatsioon ehituse juhtimises, see on midagi salapärast. Me ei saa seda teha laboratooriumis. Me ei saa seda kuhugi messile välja viia. Mismoodi ikkagi toimib selle kahe müstilise osapoole või õigemini isegi kolme osapoole, tellija, projekteerija ja ehitaja vahelised suhted, mismoodi neid suhteid on võimalik ümber korraldada. See on antud valdkonna võib-olla kõige salapärasem ja samas ka potentsiaalselt kõige enam efekti pakkuv teemade ring. Ning tänasele üritusele oleme siis kokku kutsunud esinejaid laiast maailmast. Kõik, kes te päevakava seina peal vaatate, näete, esimeses kahes osas on esinejaid siis USA-st. Tagumises plokis on meie põhjanaabrite esindajaid. Ma siis ei hakka seda päevakava praegu ette lugema, aga puht korraldusliku poole pealt püüdke siis nüüd jälgida seda, mis ekraanide peal hakkab toimuma. Põhiesineja, kui ta võtab siin mikrofoni ja puldi kätte, hakkab slaide juhtima ja see ingliskeelne slaidiseeria peaks minu poolt võttes siis ekraani peal liikuma. Ja kui see esinemine on meie kätte jõudnud õigel ajal, et me oleme saanud teha tõlke, siis siin vasakupoolse ekraani peal hakkab jooksma selle sama slaidiseeria kerge eestikeelne tõlge. Nii et meile kõrvadesse keegi tõlkima ei hakka. Ma olen palunud meie külalisi, et nad räägiksid selgelt, arusaadavalt, täislausetega, nii nagu korrektsed inimesed akadeemilist loengut ikka peavad. Nii et ilma tõlkimiseta ma saan aru, et me oleme ka juba nii palju arenenud, et saame hakkama ka võõrkeelse, eelkõige siis ingliskeelse teksti kuulamisega. Ma ei oska rohkem tehnilisi küsimusi teile praegu siin kommenteerima hakata. Kui kellelgi on tõesti mingisuguseid probleeme, siis pöörduge ja leiame vastused. Kõik need, kes on võib-olla mures olnud, et ei tea, kas neid aksepteeriti tänasele üritusele, et nad on ammu registreerunud, arvet pole tulnud, aga nii nagu normaalses turuühiskonnas on, kõigepealt teenus ja siis tasu, nii et kui te olete kohal, siis pärast seda saate tunnistuse ja hiljem tekib ka arve, nii et ärge pabistage ega raha korjamata ei jää. And with these words, I would like to start introducing the first man for today's presentations. This is Michael Bade, who has traveled half the world from the other side of the earth. So coming from United States, actually his background is architecture, but I understand he is working in the university and responsible in the university for the whole facilities of the university. And the topic of his presentation today is he tries to explain why public clients need all these kind of fancy things as lean construction, IPD, BIM, because there is still a long step for us to go until this step, until this stage, as I assume you have reached, that university says, please, if you are a contractor and you want to deal with our university, you must come with BIM in your pocket. Michael, please come here. Here's just the micro for you. Please try to fit it. And nii, meil võib niisuguseid väikesi tehnilisi asju olla, me pole ju proovinud veel. Nii. It seems, Michael, you are okay, and then your presentation should be also
mikrofon sisse ka lülitada.
Switch in your micro.
Thank you.
So, the floor is yours. Please go ahead.
Thank you very much. If you at any time want to stop me and ask a question, or if I've spoken too fast and you need me to slow down, please raise your hand and I will stop. My name is Michael Bade. I'm Associate Vice Chancellor and Campus Architect for the University of California, San Francisco. We are a large health sciences only university. We have about 23,000 employees and 4,000 students. And we run several large hospitals in San Francisco. And today I want to tell you the story of why we have started to use lean construction and BIM and target value design, and the benefits that we have found in doing this. So first I will talk a little bit about our understanding of lean construction, introduce our university, talk about why we use lean construction, talk about what is target value design and how do we do it, and then give you an example and talk through each step in the process of designing and building that example, which is an office building. And then hopefully some question and answer. I will stay here today for the day, and anytime you want to talk to me, please just come and do that. So some differences between lean construction and traditional project management. I've put these slides in for you to read at another time. I don't want to talk through each one. I think it's pretty evident what the differences are. But on this first slide, the two points about lean construction, managing the interaction between activities and their effects and optimizing the workflow, is for us the key fundamental philosophy. Why do we do this? It's because the problems that we have had in the past with design and construction of buildings all result from the old process, which cannot do these two things. And I am both the person who conducts the orchestra, and I am the impresario of the circus, and then when the circus parade goes by, I go and clean up. So when a project finishes and the results were not satisfactory, I have to fix it. So I am involved in lawsuits, litigation, and I hate that. So with Lean, we've stopped having to do any more cleanup after the project. So there are 4 slides that talk about the differences. So what Lean construction tools do you have to accept in order to get the benefits from this process? And the first one that I put is shared project control. In traditional construction, at least in America, the control is a value that the owner or the general contractor try to monopolize. And to do Lean, you have to share the control of the project with the people who are doing the work. And in sharing that control, they take responsibility. And that's a fundamental principle that makes this whole process work well. We try to optimize the whole system through collaboration and learning. We seek continual improvement, although we know that perfection is impossible. We focus on delivering a project that is desired by the owner. In this case, the owner is a community. We are an academic community, and the asset, the building, needs to support the way that community works. And this is a complex question in design. And if you don't have a project that is focused on this, it will fail. We try to create value flow, or the flow of value into the project through the decisions that are made by the designers and the builders by removing obstacles to the creation of value. We try to create pull production, and we try to mistake-proof the process. All of these are very large subjects, and when I look at our projects, I do not feel like we are experts. We are just beginning to learn how to do this. With the last planner system, this is the system developed by Professor Glenn Ballard and Greg Howell and Lauri Makallio in Finland. Not Lauri Makallio, Koskela. We use this throughout our projects. We first create a milestone schedule, and then the community process of doing the design and construction begins. And the people who are working on the project collaboratively pull schedule each milestone phase. They the list of tasks that they need to fulfill is under the weekly last planner workflow management process. But I want to ask, who are the last planners? And the answer to this question is the people working on the project. The point of the last planner system is to push the control of the process down to the people who are doing the process. So when you're in design, as Romana will talk about, it's the people who are working on the design who are scheduling and managing the process. If you're on the construction site, it's the people who are doing the construction work who are managing that process. And the lower down you can push the responsibility, the better the outcome. We use target value design to design our facilities. And This is the result of about 8 years of experiments. We build buildings that we will use for hundreds of years. In fact, we have a project right now to renovate 2 buildings that are 100 years old for the next 100 years. So when the university builds an asset, it builds it with the intention of keeping it forever. This is very important because fitness for purpose then is really the definition of value. And we try to develop clear, purposeful design criteria and performance parameters that the designers and builders can use to know what value they are creating. And I will use the example of the building later to talk through this, this process. Target value design organizes the production process as well as the asset being created. An example of this will be, I'll talk about later, with the office building. It was a design build competition, and on day one, the people who were going to manufacture and install the exterior of the building were at the table with the architects designing, helping to design the building, so that the deepest technical questions were being addressed from the very start of the project. This is very desirable. We use a big room organization on our projects. We are lucky enough to have enough land to make a big room. Sometimes this is a challenge. Where do you put the construction trailer that becomes the design office as well as the site office? But what we are trying to create is an integrated team workplace. And usually people don't know how to behave in a big room when the project starts. They've generally never done a lean project before. And so working with the contractor and the designer, we do a lot of training. We need to tell people, you know, this is different. Explain how it's different so that they will know how to behave during the project process. America is a very famously litigious country. We have lots of lawyers and lots of lawsuits and long contracts. A contract to build a building of ours is about like this thick. And nobody can manage with a contract like that. So we try to use the contract to explain the positive as well as give rules for fighting if something goes wrong. But by balancing the negative with the positive, we try to help give incentives to do the right thing. I find that contracts are very limited in value if, and you never need to look at them if the project is going well. And so if we train correctly and focus on common objectives, then we can set this big contract aside and just do the work in a very direct way. That means that you really have to communicate all the time and focus on mutual problem solving. And that process breaks open traditional team boundaries on the construction site. As an owner in a traditional process, I would never expect to talk to second-tier subcontractors or have them come to me to seek help in solving a problem. But in the lean process, this should happen. That means the owner has to be continuously involved with the designer builders. The owner cannot stand back and say, that's your problem. That doesn't work. And the team has to focus on attaining the desired outcomes of the project. So what is UCSF? We are a campus in the University of California system. There are 10 campuses. 9 of them are general universities. They have undergraduate students and graduate students and many departments. UC Berkeley has 24 schools within the university. We have 4. We have 3,000 students and 1,000 postdocs and 1,600 medical residents. In America, a medical resident is a doctor in training. They have completed their medical school, which is 7 years, and then they have 2 years of work in training. We are a very large research institution. We receive the most research grants from the U.S. government for medical research of any university in the U.S. And we're ranked number 1 in all categories. We are a very large business, in fact. We receive more than half of our revenue from clinical services. So we operate 2 hospitals of our own, and on February 1st, a third will open. And we provide the doctors for 2 more hospitals in San Francisco. So right now 4 and soon 5 large hospitals. And we receive a very small amount of money from the state to fund education and some collaborative research. So we are almost a completely private institution. We have many sites in San Francisco, 3 main ones. Our Parnassus campus, which is the traditional core of the university, a new campus at Mission Bay, and a small campus at our Mount Zion Hospital. We are an urban campus. Other campuses in the UC system are buildings in a park, and they are in one place, and there's green lawn between the buildings, and it's very nice. And our sites are mostly urban sites, and it's a completely urban character. That means we have a deeper relationship with the city of San Francisco in terms of planning than our other campuses. This is a large enterprise, and we have many challenges, one of which is that we do not have enough capital for all of the purposes that we need. We are growing a new research campus at Mission Bay, and yet we are reinvesting in our existing facilities. We're very near the San Andreas Fault, and you may know that in 1906, San Francisco had an enormous earthquake that destroyed the city. We're 4 miles from that fault, about 6 kilometers. So we have to design our buildings to a very high standard structurally. We have many 50-year-old buildings or older, and these all need to be brought up to date. San Francisco is a very dynamic place, and new work styles come into being very easily, and we have to respond to this. So these are some of the challenges that we have to face in creating new facilities or renovating our existing ones. This is our Parnassus campus. You can see the high-rise buildings. There are 2 15-story hospital buildings and 3 15-story lab buildings, which are joined on every floor. So you can walk horizontally through all of those buildings on each floor. Our Mission Bay campus is our new research campus and the site of our new hospital. This is where most of our investment is flowing. And it was with our Mission Bay campus in the early days that we made a number of mistakes in design and construction, which I'm still cleaning up now, over 10 years later. But, you know, some people say a mistake is too valuable of a thing to waste, and we try to learn from our mistakes. And so that learning process led us to lean construction. And so why did we do lean construction? Our original project delivery method was design, bid, build, or a very simple construction manager at risk model. Of the first 5 buildings at Mission Bay, 4 fell into litigation. And I'm still working through that process with lawyers and the courts. We had typically late delivery and delay claims. We also had claims, so those were claims by the contractors against us. They also claimed based on inadequate construction documents. And so the outcome for the university was our budgets were not dependable. And that's a very difficult thing in a social institution. And so my boss's boss then asked me to figure something out. So in 2004, we connected with Glenn Ballard at UC Berkeley and joined the Lean Construction Institute. I am actually this year the chairman of the Lean Construction Institute in the US. We saw the early Sutter Health results. Romano will talk a little bit about working for Sutter Health later today. And we started to modify our contracts. And this was a difficult thing to do because normally the central administration of the university controls those contracts and does not let each campus change them. But we made a strong argument, and so they decided to let us do this. And so we made 2 new contracts, and we still use these contracts. One is a construction manager at risk with design build subcontractors, and the other one is a lean design build contract. So our first 2 projects were laboratory buildings. They were the experiment, and we liked the cooking. The meal tasted great. So we, when our new hospital came, which is a very, very large project, $1.5 billion, we used what we learned there. And then we took what we learned in our hospital process and used that to develop a lean target value design contract. That's the latest version for our Mission Hall project. And a target value design approach for our seismic renovation program on Parnassus campus. So that we say in America, in a nutshell, that's the story. The cardiovascular research building, 26,000 square meters, a full floor animal facility on the top level, 3 levels of labs, and a clinic. Our stem cell building, which was built on the Parnassus campus, this is a day's worth of discussion. This is an amazing project, and I don't have time to get into it now. This is our new medical center, which will open in 2 months. And our Parnassus seismic program, which is renovating the 2 buildings at the bottom here on the right, and many laboratory spaces in other buildings. The university has a number of delivery models, different contract forms. The ones that we use are number 2, 3, 4, and 9. So we use a best value project selection process, and we use that for small design bid build projects, for our lean CM at risk contract, for design build, and for job order contracting. That's JOC. The other university contracts we don't use. So for major projects, we use our, for projects that is hard to do fully design build, we use the CM at risk with design build subs. And then for new standalone buildings, we use the target value design build. So what is target value design? Target value design is a practice that tries to deliver what the customer values and develops the design within project constraints. That's a very abstract way of saying it. A more poetic way is an application of engineer Ono's advice to lower the river to see the rocks, to self-imposed necessity as a means to innovation and continuous improvement. Engineer Ono was the man at Toyota that developed their version of lean. It strives to reduce waste and rework in the design estimate redesign cycle. It requires a real fundamental shift in thinking from expected costs to target costs. It requires cross-functional teams. It admits that no one person has all the knowledge in a project, and it really requires an integrated product process cost model. And I'll talk about these ideas in more detail. So we have limited capital funding, and target value design allows us to get the highest performing facilities for the money that we have. We use comprehensive performance specifications to shape the design and to measure the performance value provided by competing proposals. These performance specifications are a form of self-imposed necessity that promotes innovation. We specify the amount we will pay for a project, and then we take proposals and use the performance specifications and the design criteria to measure the value of the proposals. And for us, value is performance for money. And it's both the soft performance, the fitness for purpose of the process of the project, as well as the quantitative performance, structural performance, energy performance, things you can measure with numbers. We try to reduce the waste and rework by asking the teams competing for our projects to develop comprehensive execution plans, and these have to be holistic. They cannot just be part by part. We are using in this process a dynamic concept of value, which accepts that value at any given cost point is a function of the qualitative and quantitative performance of the asset. So we're regarding a building as an asset. It's something that is going to support our medical research, our clinical care for 50 to 100 years before we really renovate it. And we want to know what we're getting for the money. And so this is how we do it. Target value design is a challenge to design build teams to expand the envelope of the possible. So the cost that they will get for the project is fixed. The variable is how well does it perform. So we use maximum allowable cost as our design build cost target. The competition for the project award is used to maximize the building performance for a fixed cost. The performance specification allows measurement and valuation of the asset performance quantitatively. We translate it all into numerical values. The design criteria allows measurement and valuation of asset performance quantitatively, and we use a ranked scoring system so that the top ranked proposal gets 100% of the points in any one category. The second ranked proposal gets 2/3, and the third ranked proposal gets 1/3. And this takes bias out of the judging process. Usually it's much easier to say which proposal performs best, and then the points come automatically. With our new hospital, we are bringing many new people to work at the Mission Bay campus, and so they needed a place to do their academic work. Remember, these are doctors who are also university professors, and so they are involved in medical research. They might be running clinical trials. They might be studying epidemiology, which is the spatial distribution of disease. And they needed a place to do their academic work and for their departments to locate. We're a very fast-growing economy in the U.S., fastest in the U.S., and the growth is driven by the software industry. For many years, we were able to rent space in town for programs that we could not build for, but now that's turned around. It's cheaper for us to build than to rent. The rents in San Francisco are like Manhattan, and so we decided to build a building that would support the academic program of the new hospital. So the program is 26,500 gross square meters, 7 floors, 1,450 workstations. This will house 34 clinical and research departments. It will provide workspace for 750 clinical faculty and 700 departmental staff, with ground floor classrooms and a conference center and some retail space. What the problem that was really we really had to confront is that the work style question. The old way of working is that you had, if you were a faculty member, you have an office, and in your office is your desk, and sometimes you go to a conference room or a classroom, and sometimes you go to the break area and get coffee. But the real way of working nowadays is much more diverse, and part of the issue that we had to face with design was getting people to realize that they think they're working the old way when in fact they are working the new way. So I want to talk a little bit about risk management. Because the hospital was going to open on a date certain, we needed this building to be completed on time. We needed to support the research, teaching, and patient care community that would be in the building and have a long-term value horizon. We were willing to trade control of the process of design and construction for certainty of outcomes. We decided to emphasize performance objectives that deliver long-term value. And so that's why we decided to use this delivery model. As I mentioned earlier, we have a 3-level performance specification that we use for a design-build competition. The tiers allow us to categorize performance. We had a fixed cost of design and construction of $93.8 million, including furniture and a high specification IT system. We had a fixed program. We used a best value process to award the contract. And basically what that is score the proposals, divide the score into the cost, and award based on the lowest cost per quality point. In some projects, it would not be a fixed cost, and the winner might not be the lowest cost. But in this case, we had a fixed cost, and so it was really who got the most value into that fixed cost. This is important. The contract is to design and build a building with the specific performance levels proposed in the competition submittal. So often a construction contract is to build a building, and the design contract is to design a building, and somewhere in between the two, a guarantee of performance is lost. It's very hard to enforce. This contract, the guarantee of performance, is very simple to enforce. If they don't meet it, I make a phone call. They come and fix it. It's a huge change in a country like America where everyone is fighting all the time with lawyers. Our contract emphasizes a quality assurance, quality control process, which has deep roots in Lean, and we actually use a pretty straight Shingo model. Susumu Shingo was one of the originators of Lean in the automobile industry in Japan, as a framework for asking the team to create a quality assurance program for the project. So we developed planning and design criteria, 400 pages. We have I can't go through all of that in this talk, but there are, this is the very highest level of performance setting. We wanted a quality working and learning environment, a model of architectural and urban design, a high-performing building, high level of environmental sustainability. We wanted it to be durable and long-lasting, and an asset that we can efficiently maintain. And so those are the various highest level expression of the performance desire. And then we work it down and down and down with more and more detail in the document. Just an example of a page from the technical criteria. This is around structure. We required a very sophisticated structural design methodology that it uses what we call a non-linear analysis, which is a 3D computer model that is stressed with known earthquakes repeatedly, and then a Monte Carlo simulation is built out of that. So many thousands of times with 6 or 7 different earthquakes, and then you can see probabilistically how the structure will perform, and then you can make modifications that address what you learn, the issues that come up. And so this is just an example. I can share this document with people if you are interested. And then the consulting team evaluated the technical criteria. We worked with the users, a group of 27 faculty members, to evaluate the design quality and the the way that the interior is designed as a fitness for purpose. And we published the evaluations for each of the 3 proposals. And then we did a ranked scoring exercise. This is a score for one of the contractors, and we just enumerated how many times they met the base or required level, how many times they did not, how many times they met Tier 2 and Tier 3, which are 2 higher levels. I'm going to have to take my sweater off because it's very hot while I'm wearing it. It's standing by the radiator. That'll do. That'll work.
Valesti läks mikrofon.
Okay. Okay. Then we compared all 3 against each other. And then we did the calculation of the cost per quality point. And we had a winning team. And what we got for our money was quite a lot. This is a cost that is below the private sector cost in San Francisco for a typical or a similar project. The structural performance is much higher than code requires. Immediate occupancy is actually a technical description in California structural engineering. It means that for a given class of earthquakes, you can walk in and use your building. And not only the structure is fine, but all of the non-structural systems, the IT and electrical and plumbing supports and all that, no broken pipes, no broken wires, the building works, it's still watertight. And California has the toughest energy code in the US, and the performance of this building is calculated to be 25% better than the energy code. And then most important, the faculty committee evaluated the winning proposal highest of all for workplace design. The benefits of this are we gave the design team dependable information. They had almost no questions of us during the design process that went on after the competition. And most of the questions were answered by looking in the book that we published for them. The performance specification allows us to focus on outcomes, i.e., what I mean by outcomes is how does the building work? Will it fulfill its objectives? And we're not trying to achieve those outcomes by focusing on the means and methods that we gave to the contractor to be responsible for. It enables an integrated team process. So the original contract value was $93.8 million. The completion contract value is $99.2 million. It's just a little higher than this right now. And almost all the change orders were driven by requests from UCSF due to new AV, audiovisual, and IT technology. We set the project up this way so that we could purchase the equipment at the very last moment because the IT and AV equipment is constantly getting better. and we didn't want to buy it 3 years before we were going to be built or 2 years before we were built. We wanted to buy it 6 months before we were built and install it. We awarded the project in August of 2012, and we started foundations in March of 2013. We finished the structure, which was a concrete structure, in December of 2013. Closed the building in April. It's California. We don't have any snow. Work through the winter. It's easy. Substantial completion on September 5th, and classes started September 15th. So 18 months to build, and about 6 months ahead of that to complete the design. So 2-year process. We had no claims. Ground floor is mostly classrooms and some retail and the back of house support space. Typical office floor, this will not look like anything you've seen, because what this is an activity-based workplace. Nobody has a private office. All the senior faculty have open office workstation just like everybody else. So space is not part of the academic reward system anymore. If you need privacy, you go to one of these little yellow rooms whenever you need it. No reservation, walk in, work for a day, work for half a day, have a conversation with somebody. When you're done, you leave. Go back to your desk. If your team needs a place to work, you can grab one of these. No reservation needed. Only the larger rooms, the bluish rooms, need a reservation. So most of the time, the people who have a desk here are working in the hospital. They're delivering medical care. They come here 2 hours a day. So, okay. This one? Yeah. So they'll have their academic workplaces here, but if they need to write a paper, they might take one of these rooms, or this one, or that one. It's fine. This allows us to fit many more people into the building than if we had a traditionally designed building. So this is, and it also simplifies the management of the facility, as you can imagine. Everyone gets the same workspace, so you don't have to manage, oh gee, I have more faculty than offices, which is actually typical for us. You can always fit somebody in until the building is full. One of the things that Lean does is to make management visible, and the site superintendent for the contractor that built the building made this schedule. And if you look at it, it's a section cut through the building, and he has marked the months across. And then you can see the construction activity. The green lines here are shoring, and so this is the concrete construction schedule, and the shoring was removed from the top levels at the end of January. Because of the performance requirement for the structure, they had to shore 4 floors. They removed the first 3 earlier, but then they still had 4 floors of shoring to remove at the end of January, and they started right there, and then they took the rest out there. Then you have GFRC exterior panels is this flow here, and then the interiors is this flow here. and then occupancy starts here. And actually, we finished the entire building. We actually also finished this piece in the beginning of September. The weather, expected weather, is marked here. So this is a visual communication of the entire project in one image. And we found it tremendously useful for both the workers on the site and anybody else who had an interest. So on this project, we used Last Planner. We used the big room. We used an access floor system in the building itself, which allowed many benefits in construction. We had a takt time organization of the concrete structure construction process. We used a lot of prefabrication for the exterior envelope. And we had a quality assurance program, which was part of our commissioning process. Classes started on time and the building is working beautifully, which typically was not our experience 10 years ago. The concrete decks were 200 millimeters. The shear walls were 800 millimeters. So it's a very heavy concrete structure. And as you can see, lots of reinforcing. We had to figure out how to build the reinforcing quickly. And so we actually spent money on more reinforcing, which simplified the construction so that the whole process went faster. And that's an example of the kind of choice you make in Lean, in that you're not letting one detail drive the whole. So the detail of reinforcing is not driving the project. We over-design the reinforcing so that we can get the whole structure done more quickly. We built the floors on a 5-day pour cycle, 15 days for each deck, which is fast. Example of the schedule flow for a piece of the structure. We used A3s for making decisions, critical decisions during the design and construction process. This is just an example. I'm not going to go through it. I can't even read it on this screen. Yeah, so we had questions about how to handle the academic records that were being brought. So many of the professors are working on clinical trials of medicines or medical devices. And clinical trials require a submittal to the US government for approval of the medicine or the device. And so the records that they keep are very large record sets, very heavy in paper. And so we studied this using an A3. We did a lot of off-site fabrication, especially of the exterior envelope. 361 panels, and I'll show you. So the company that manufactured and installed the exterior built this rig, and so they had the opaque panels, the glass fiber reinforced concrete panels, and the windows set up with the rig so that they could install them in the yard and build the panels in the yard. And this jig allowed them to do an entire panel. So that panel goes from here to here, actually to here. This is solid. It's going to go right there. These are finished panels. Solid glass, solid glass, solid glass. And then they went on the outside of the building. We put a raised floor system throughout, which distributes air as well as IT. There were 66,000 floor tiles and 78,000 pedestals, and a number of floor finishes. The big room was a really essential element of the process because it allowed people to really get to know each other and to develop good communication, so that if a problem came up, they were friends rather than enemies. And you can work out a much better solution with your friends than you can with people you don't know or who you might only know a little bit. This photograph is of the last planner workflow management process in action, and you do it in real time with the people. These post-it notes, a different color for each sub with the workflow shown, is a result of the foreman standing here and negotiating with each other how they're going to work together, who will do what first, and then who will do what second, who will do what third, to develop an optimized process. This is a very, very powerful process. And it doesn't require any more technology than a piece of paper with some sticky on the back. We used box.com to house all of the master drawings. We used a software application called BIM Anywhere, a very powerful application. It brings the BIM model into the field so that you can see the BIM model on an iPad in the field. You can take a picture of something that isn't being built right, and there's a difference from the construction to the model. You can send the note to the foreman of the crew that's responsible. And then the other really great thing about BIM Anywhere, it's the first software I've seen where BIM information can be used for facility management after the project is done. And with a raised floor system, all the desks are on top of the floor. All the IT is in the floor. All the electrical is in the floor. We have fan coil units in the floor for temperature control. If the facilities department needs to fix something or change something, how do they find the thing they need to fix or change without ripping the floor open? It's with the BIM Anywhere, because the iPad has gyroscopes inside, and you can, when you're in the BIM model in BIM Anywhere, you can point your iPad in a direction and it will orient to what you're looking at in the BIM model and show you what's inside the wall or inside the floor right there. And you can measure it on the iPad with the actual dimensions. So this allows for facilities department to come in after the project is done and go right to where they need to go without having to rip everything open and find it. Big advantage. I think the pull scheduling process really lived up to its promise on the project. This is just a lot of information for the deck that will be distributed. Visual management was used on the construction site, and we had a bulletin board which explained to the workers where the hazardous activities were going to take place every day, so that they would know and be able to stay out of the way. We also posted the visual overview of the master schedule and the weekly site plan. And here's an example of the of a slightly different visual management on the site, but this is about keeping the project clean, which they did a very good job of. The quality assurance process worked very well. 98% of all inspections were passed, and the visual management was really a key success factor in that. We focused on some critical processes like concrete deck inserts and rebar placement, on wall framing and closing in walls. In the few places we had ceilings below the slab, we focused on that, and on underfloor plenum integrity. Having a office air system that depends on a raised floor, you have to limit the leakage from the floor plenum to about 11%, which is calculated into the ventilation. If you have 20%, you're going to have ventilation problems. And so making sure that the floor plenum was tight enough so that it performed within specifications was a very important thing to do. And the team used BIM Anywhere to track all the field deficiencies using the BIM model, which allowed for real-time tracking and allowed for the people who were going to fix the issues to know exactly what to do. This is an example of how they mapped, used mapping in the quality control process. This is what an iPad view of BIM Anywhere, the model in BIM Anywhere, looks like. And in this case, one of the field engineers has is looking at the systems in the floor without the floor tiles in, so he can see exactly what's under them. For instance, we had, these are statistics that just show how few problems we really had. The last planner plan percent complete rate for the project as a whole was 83%. And the system really allowed the foremen and superintendents to commit to each other what was going to get done. What was really important in what I just said is commit to each other, because they're making promises to each other about how they're going to do the work together. The weekly negotiations regard the commitments they make, the handoff points, and achievement of mutually desired outcomes. I think the biggest takeaway from this process was that the training people over time to understand the fundamentals of lean construction and the big picture expectations for the project really paid off. We had a team of builders and designers who worked together like this, and that was very powerful. Our construction company project manager, her lessons learned was don't let project execution run on autopilot, and don't take anything at face value. Always confirm that people can meet their commitments and make sure to review their backlogs. In terms of the process for building a building, for designing and building a building, I think the data-driven design process that we used was very effective. The enforceable performance specification worked very well. But in the proposal process, we can make some improvements. And one of the improvements is to increase the compensation to the teams. We got more for our money than we than we paid out in the proposals. And so I like to make sure that we pay for what we buy fully. So the team met beat all of the milestones that they contractually committed. They maintained an over 80% project plan percent complete, and they found a way to build the structure, which was very complicated per the construction schedule. This was when they were just about to start removing the shoring from the upper levels. It was Christmas time last year, and the project site superintendent made a Christmas tree on the tower crane. So here are some pictures. I mentioned a little bit about how the university is a community, and this feature of the design is a community forum that links pairs of floors into a larger environment. And it's not an atrium under the building code because it's only 2 floors, so we didn't have to pay a lot of money for smoke exhaust and other fire control systems. But this gives a place for the departments on the floor to meet, have coffee, to develop casual conversations that lead to research partnerships. And so far, the word from the site is that this idea is working very well. Questions?
Nii, poisid ja tüdrukud, nüüd on küsimuste aeg ja nagu te teate, alati esineja või lektori jaoks on kõige parem hinnang see, kui on hulgaliselt küsimusi. Aga kuna me täna võtame kogu seda etendust ka linti, siis on ainukene kindel palve see, et kui keegi hakkab küsimust esitama, siis just nimelt selle sama toru sisse, mis minu käes on. Ja mingisugune noorhärra jookseb mul siin ringi ka, kui vaja on, et see lakutud peaga poiss on siin mikrofoni kandja, aga ma võib-olla alustaks küsimuste joruga ehk ise, I made just a short introduction how they should ask the questions using the micro and so on. But can I start questioning you?
Please.
Yeah. In your presentation, you actually blamed lawyers. And you said that US is just a country of lawyers, and so everything what you are doing, it's just work for lawyers. But for sure, you are just the vice chancellor, so you are the white-collar team leader. What's the size of your team, your client's team, and how many lawyers are involved by the university for this project, for example?
This project had 1 lawyer involved, and that was only in writing the contract.
And was he involved from your side, or the other contractors had the lawyer? It was yours.
She was our lawyer.
She, okay.
And so from that point of view, I really like this project because if a project becomes subject of a lawsuit, you will spend 6 to 10 years in the American court system and spend millions of dollars.
Okay, then you have been lucky, but can you say a couple of more general words why this attitude and this image about US construction management system that it is based on lawyers. Where's the background to this?
Well, it did not used to be that way. 50 to 100 years ago, I think the building process was much simpler and had and more direct. But in the 1970s, the U.S. experienced very rapid inflation, and our construction process changed dramatically at that time, post-Vietnam War inflation. And so what had been a more integrated process was disintegrated into pieces in the attempt to control each part of the process as a miniature process and isolate problems from other parts of the process. That led to conflict between the process components. And those conflicts became serious enough, they were about large amounts of money, that people would use the court system to try to resolve that. What we are trying to do is to put all that back together. We have a nursery rhyme about Humpty Dumpty, the egg that fell off the wall and broke, and trying to put the egg back together. That's what we're trying to do, is to make a more simple, integrated process where the people who are doing the work can be directly responsible, but also be invested in their work product. And when you can achieve that, then you can take the conflict out of the process. And then the role for lawyers really becomes one of writing good contracts. And you need good contracts. And that's where we're trying to be, is there is a role for lawyers, a very valued one, but it's in writing the contract, not in managing the fighting.
Hey, you said in your lecture that like what did this new approach mean was that you as a customer kind of got a less stress or like stress-free process and in budget and on time delivery. But to have the like some sort of data from the other side of the table as well, that how did it end up for the customers, that, or not customers but the contractors, that you got a lower price per square meter and as an average and higher performance. How did it end up for the contractors? That how was their performance in the end of the day? Did they earn their average what they would get through the court, or did they stay below that?
Well, we all avoided the cost of litigation, so that was a factor in lowering the cost of the building. They expected a less litigious process. We purchased the building at a time when the construction economy was very low, so we also got a good price at that point. But we were able to build the building for the within the expected return of the subcontractors and the contractor. So everybody broke even and made a little money on the project. At the time, they were only hoping to keep their workforce within the company. They didn't want to let people go, so they were happy to have the project, and they would basically do the project for cost plus a little profit. Now, when we have more work in the local economy than contractors, everybody is expecting more return, and they're getting it because you have to pay to get people. So times have changed a little bit, but nobody lost on the project, and that was, I think, their big criterion was they would do this, but they did not want to take a loss in doing it. And we were able to achieve that.
Hello, Michael. I think, correct me if I misunderstood you, but one of the most important aspects that you mentioned in your presentation was that the value is not equal to the money, but it's equal to the expectations and the business case of the client.
That's right.
And if I understood it correctly, can you say that once more? Because this is something, a mental shift that has to happen also in our industry.
Yes, Ergo, thank you. This is a very important point. Normally, with a traditional process in America, you hire an architect, they design a building, they do what are called construction documents, but which in reality could never be used for construction. The real technical documents are the shop drawings. And somewhere between the finish of design and the completion of the building, something is lost. And often what's lost is the actual performance of the building. And so you had hoped to get a mechanical system that used small amounts of energy to keep the building temperature stable, or a good structural system, or high durability, or good fitness for purpose. And at the end, the building never lived up to those expectations, and there was no mechanism for it to do so. So what we did was we made a trade. We wanted certainty of outcomes, i.e. high value in terms of structural, energy, workplace, fitness for purpose, and we were willing to give the control of the design and construction to the team and get out of their way. So we were there for their questions, but otherwise we really let them run with the job. And their commitment to us was to deliver a high-performing building. And that's in the contract. So if something isn't working the way we all intended, I just make a phone call. They come and fix it. Simple.
Very good. Well said. I know that because we had a conversation last night at the dinner table, but I would like to ask the questions still about this post-evaluation or the systematic study of the already delivered projects that are in use by the people, you know, acting or using this building for their purposes and functions.
Okay.
Have you planned to do that, and
yes.
how?
Yes. So another big subject that I don't have time to talk about today is a data-driven design process. And what we are doing is, because we're making environments, working environments for large numbers of people at a time, we can't, we need to study how well those environments work, the physical environment and the workplace design, when they're in use, so that we can take the information we learn and address it in the design of facilities that come later. So we have engaged a research team from the American architecture firm Perkins and Will, who are working with a professor from University of Michigan and a professor from Georgia Institute of Technology to understand the working environment. And so they are doing pre-occupancy evaluation of the workplace that people leave behind and post-occupancy evaluation of the workplace they move into. And then they will compare the two. And then on the technical level, for 2 years after the handover, the design and construction team will work with our facilities services department to monitor the building technical performance quarterly, making sure that the energy use is within targets, to make sure that ventilation is good, to make sure that acoustical properties are met, and things like this. So then periodically we will merge all this information we are going to start design of 3 new facilities in 2015, and so we're expecting the workplace evaluation in June of 2015, and we'll immediately start to use that to program our next procurement processes. And so this is how we're going to work from now on. We're going to always study each building we build and take the results of that study and use that to inform the program for the next projects. And we're going to do this formally. And I'm restructuring the way that we budget for projects so that that study cost is in the projects, part of the design. I find that the design is much more efficient if the information you give the designers is dependable. And owners, one of the worst things that owners do is they do not develop dependable design criteria. If you have dependable design criteria, design can be quick and sharp and to the point. And if the owner cannot say what the owner wants, then the designer is hunting for a solution. And it's very expensive, and you're always missing the mark.
Hello, I'm Jani Myllymaa from Vienova System Finland, and first I would like to thank you for excellent presentation. It was good. So I have a question regarding target value design. You said about those design criteria that dependability is one good value for those, but in your experience, what are the key success factors for defining good performance specifications and design criteria?
Well, first of all, a good performance specification has to have a clear target for the designer. And so in most cases, we were able to develop a minimum acceptable criterion and then 2 tougher levels above that. Not for all, but for most. And these have to be expressed in a way that the designers can use. We had an architecture firm, Gensler, develop the performance specifications for us. And their job as a major architecture firm was to express the performance criteria in ways that the architects and engineers could use to design the project. It got very technical, and we had in each performance specification, and there are 250 separate performance specifications in the system, we have a method of verification of performance. And it can be simple, that the solution is documented in the project documents and accepted on quality assurance basis in the field, or it can be complicated, such as the building balance, air balance process, or pressure tests or things like that. So it takes a large investment to develop a set of performance criteria for a project like this. We spent $1.5 million developing the performance specifications. The Gensler had a team of 55 consultants and engineers and their own internal architects working on that project. And they did it in 4 months, which was, I think, an amazing feat. But now we have a start for something, and we're going to use the same approach and every project cycle improve the performance specifications, because we all like this as a basis for design better than one-off performance criteria.
So we will have today a presentation about big room, but you mentioned a couple of times also big room. Just through your mouth and your eyes, well, what's the image of big room? How big the room is, and what is actually going on there? Because in our society, everybody has handy or mobile. Well, everybody says, well, I am there, just give a call. Just the big room. And how many times have you been in this big room?
So I am in the big room weekly. The big room itself for this project had 70 workstations and 10 offices. And the leadership for the construction contractor and the architect had offices. My inspectors had an office. And we had some offices that people could use for quick private conversations. But then the big room was an open office. And what's really important is the seat assignment changed depending on the nature of the work. So when the structural design was being done, the concrete subcontractors, staff, and the structural engineer sat next to each other. When the mechanical design was being done, the architect and the mechanical contractors, design and construction staff sat next to each other. Because you want to put people next to each other who are working on different aspects of a common problem. And that allows them to have quick, collegial conversations rather than communicating through less effective means. And every other means of communication than talking directly is less effective. So we wanted to maximize the effectiveness and efficiency of those communications at the time in the process when we needed that. So the big room it isn't just a big room that you throw people into. You have to manage it. You have to place people next to each other who need to talk to each other based on the work that's being done at the moment. And then when that work changes, you change the seat assignment and you repopulate. Maybe some people go away and others come. That's why training has to be continuous so that the new people come in, understand why they're sitting next to somebody else and what's expected of them.
So, thank you. If we all look on watches and compare our watches with the program, we see that we are quite in time, but we haven't done a very important thing. We haven't given the applause to Michael.
Thank you very much.